Recording. We're going live. Woohoo! Okay. So here we go. Now I'm going to show you this process for iron 3 chloride. And what we need to do is find out what we want to know. We need this value. We need to figure out what the individual charge or what the charge is on each iron ion that's present. And we know from the formula there's just one iron ion present, but we need to figure out what its charge is. Now, most compounds, like if we know if the partner is a 1-, then the subscript will just tell you what it is. But if it's not, which I'll show you an example of that next, if it's not, then this process I'm going to show you will work every time without fail. All right, so where did I get the 1- for the chloride? I went to my handy dandy periodic table of ions, and I find that chloride is on the right-hand side, upper right, it's right here, and we see it's a 1-, and these are all the halogens. Now, hydrogen can be a negative ion or a positive ion, so they put it over here as a negative ion as well because it's a 1- when it's a negative ion. So anyhow, that's where our 1- comes from, that we wrote right here. Again, at the bottoms, I use a line to divide my compound into the positive ion and the negative ions, and then I figure out the charge. Usually it's the charge on the negative one you'll be able to determine from your table of ions. And again, the reason we have to do this is because many of these metals, they're called transition metals. Many of these metals in here have more than one charge possible, and you have to represent what its charge is with a Roman numeral. So we've got to figure out what the charge is on each metal ion, and then that tells us what Roman numeral to use. The other concept that we have to know and remember is, see, if you look at these compounds, these formulas for these compounds, none of them have any pluses or minuses, which tells you they are electrically neutral. Okay, they're electrically neutral. So that means the total charge, which I represent here at the top, the total charge will be exact opposites when I'm done with the process. All right, so I determined that from my handy dandy periodic table of ions that chloride, each chloride ion has a charge of 1-. I multiply, that's why I have the multiplication sign here. I multiply the charge of each ion by the subscript, and that will get me the total charge. So 1 times 3 is 3. So that tells me the total negative charge in this compound is 3-. And because I know it's electrically neutral, that means by default that the total positive charge has to be 3+. Now all I do is divide my total positive charge by the subscript of the metal. And the subscript's 1, so 3 divided by 1 is 3+, and that tells me the charge on the iron ion is 3+, and I represent that in the name as iron 3 chloride. So how did we do on that? Did that work for you? Let's see, there's one down here. Okay, do you have any questions on what I covered there? Thank you, Jada. All right. So I'm going to put in here, let's see. Bear with me here. I'm gonna add one on here. Okay. Now, if you look at this, it just looks like it's iron oxide. This looks like it's iron oxide. because it's one, it looks like it's one, it's a 1-to-1 ratio, right? Now there's two ways we can do it. We can go through this formal process, or we can understand, okay, oxygen is always a 2 minus, therefore the iron must be a 2 plus. Some of you can get it that way, but I'm going to show you through this process that I have over here. We'll go through this process and we'll derive what this value is for iron. Okay, so here we know it's FeO, so here's my O. We look at our handy dandy table of ions. Okay, oxygen is on the right hand side, it's 2 minus, and that's the only thing there is 2 minus. Okay, so I know that the oxygen is 2 each oxygen ion is 2 minus. The subscript's 1, so I only have one of them, so the total negative charge is 2, which means the total positive charge has got to be, give me my, oh my goodness, why are you doing this to me? All right, sorry, that's a ugly 2. All right, and there's only one of them, so each one's got to be a 2 plus. So that tells me that it's iron 2 oxide. Okay, how do we do on that one? Is it becoming a little more clear?
Yeah.
Okay, so let's do iron 3 oxide. I'm going to go ahead and type it in here. And then in that case, I'm going to have a subscript of 2 on the iron and a subscript of 3 on the oxide. All right, so it'll look like this. So then I'll go into my process here. Get my subscripts on here. All right, so now I know from the previous problem that oxygen's always 2 minus. So 2 times 3 is 6. Therefore, my total positive charge must be 6. 6 divided by 2 is 3. So that tells me that I've got iron 3 oxide. So again, it's a case, you know, that this is a case where the subscript of the partner tells you what the Roman numeral is. Probably 80 or 90% of the time you can get away with that process. But you know, I needed to show you how to do this process of determining the charge on each individual ion, because it's a skill you need, again, if you're going to take more chemistry, and it'll help you. I don't know if I'm going to teach oxidation numbers. It's in the chapter, but I'm not sure I'm going to go to that much depth in it. Because I mean, the vast majority of you are not going to take more chemistry. And probably my taking this course with me has convinced you, yes, I'm making the right decision, not taking more chemistry. So, and that's okay. I'm not offended by that. All right, do I need to give you more examples with the, do you want me to give you a couple more with how to do this process? This is where you tell me yes or no. Okay.
Yeah, the recording will help.
Okay. All right. So next, so that's showing you how to determine the Roman numeral. Most of the time, all you got to do is look at the subscript of its partner and do that. And you know what? If you don't get this charge thing, you'll get most of them right if you just do that. Now, just remember when you're writing the names, you need to look at the periodic table of ions and make sure if it's a metal that has, if it's one of these that has more than one form, then you need to do your best to figure out what the Roman numeral is when you write the name. There'll only be a couple of them on the test. All right, that right now I'm envisioning the test being somewhere around 40 problems, 10 ionic names, 10 ionic formulas, 10 covalent names, 10 covalent formulas, because it's, okay, it's just names and formulas of compounds, which is a, very basic fundamental chemistry skill you're expected to know when you finish your first chemistry course. All right. It doesn't, just because I say it that way doesn't mean it's easy. And I know the polyatomic ions from experience really mess with students. It's just, you've never dealt with anything like it, so this is my guess on it. I don't quite fully understand the source of the confusion on them. I just know it exists. And, I'm just making guesses on the why. I think, but the main thing is just it's just new to you. All right, let's go to, wow, why did it do that? All right. Right there, I got my cursor back. Okay. So I'm going to focus on naming, writing formulas where you have to use Roman numerals. Now, you have to use Roman numerals. Let's go to mine. I think I got the notes. No, I have it on that. All right. In the notes, it's when to use parentheses. If the ion paired with the metal is a polyatomic ion, you might need parentheses. Okay? If the charge on the metal is 2+ or more, that is, it's either 2+ or 3+. If the charge on your polyatomic ion, let me put it another way. If you need to add a subscript of 2 or 3 to your polyatomic ion, then you have to put parentheses around it first. That's probably the easiest way to say it. It's probably easier just to work through it and show you. All right, so let's we'll start with, let's see, magnesium. Yeah, I'll start with magnesium nitrate. All right, so remember when we're writing the formulas, what's our first thing we do when we write chemical formulas? Determine the what? Number one here. Got to determine the charge for each ion. So magnesium is a 2+, nitrate's a 1-. So that tells me I'm going to need 2 nitrates. But nitrate's a polyatomic ion. Now I'll go to my table of ions and show you how I determine this. Okay, I already got it. Okay, so here's oh, come on. Give me my pen. I hate it when you do this to me. All right, here's magnesium. And nitrate is right here. Okay, that's NO3-. So, I'm losing my voice. So I know it's Mg. What happened to my M? Boy, I'm having fun today. Mg NO3. I know it's that. However, I've got to add. See, I can't do NO3. I can't do NO6. I can't do N2O6. Can't do it that way. I have to do parentheses. So you put parentheses around it. Oh, come on. All right. So if I need to add a 2 or a 3 to a polyatomic ion, put parentheses around it, and then you put your subscript. Okay, another way of showing this is, remember, my compound has to be electrically neutral, correct? Just say yes. All right. Now, magnesium, I've got one magnesium, and it is a 2 plus, and each NO3, so I need, an NO3 is just a minus. So I need another NO3 so that I have 2 minuses to balance out the 2 plus. And the way I represent that is I put parentheses around it and then put a 2. All right. And that's all there is to that, but that's the number one thing students miss on the next test I give you is you know, they either don't know to use parentheses or they use them every time they have a polyatomic ion. And you know, it's not used every time. Like here, here's silver and cyanide. Silver is a 1 plus, cyanide's a 1 minus. So we don't need parentheses. That's just AgCN. But I have the other thing students do is they'll put parentheses around the CN because they're not quite sure when or when not to use the parentheses. I'll do the next one, lead sulfite. This Roman numeral 2 tells me that's a 2 plus. Sulfite, when I look at my table of ions, is a, if I remember right, it's a minus, but I could be wrong. Sulfite's a 2 minus, so we're okay. It's 1-to-1. So all we have to do is just write the symbols. This one's 2 minus. So then this one's just PbSO3. All right. Calcium is 2 plus, and phosphate is 3 minus. Again, I look at my table of ions. Calcium's right here, it's 2 plus. Phosphate, anytime you see 8, anytime you see the ending in 8 or ite, that tells you it's a polyatomic ion. All right, so phosphate's right here, PO4 3 minus. So it's Ca, and then I'll put PO4. Now, these are not exact opposites, which tells me that 2 is going to go with the phosphate, and the 3 is going to go with the calcium. So it's going to be Ca3, and then because I have to add a 2 to this, I put parentheses around it and a 2. Okay? So have I given you enough examples of Roman numerals and parentheses and when to use them to stop recording? Okay, this is again the time you get me a yes or no. Okay, so I'm going to stop recording.